Hello students, today we're going to learn section 16.1, segment length and midpoints. A point is a specific location. This is how you symbolize a point, and it's just called point P. A line is a connected straight path that contains points with two infinite directions. So here is a point A, a point B. It's connected by a straight path, but what I want you to notice is there's an arrow on this end, there's an arrow on this end. So the arrows means that it continues to go in an infinite direction. So it contains an infinite number of points. This is the letter L, okay? We can state this as line L. We can also state it as line AB, line BA, or you could use this notation. The double arrow AB, and that's line BA. So these are 1, 2, 3, 4, 5 ways to name this line. Next is a plane. A plane is a flat surface with no thickness. So a plane is a flat surface with no thickness that contains points and lines with all infinite directions. So what I mean by that is, well, this could be a line, that could be a line, these are points. This is a flat surface, so it continues on this direction, continues this direction, in all directions. So it just keeps on spreading out. So that's what a plane is. It's a flat surface. Just like this, the desk, that's a flat surface. That's what we consider a plane. We can call this plane R, or you can call it plane XYZ. You could also call it plane, you can say ZYX in any order. So again, a plane, think of a flat surface that contains points and lines, an infinite number of points and lines. Okay, next definition, a line segment. A line segment is a part of a line that has two endpoints. So a line segment has two endpoints, no arrows at the end. So that's how a line segment is different from a line. A line, if you recall, has double arrows and it continues to go on. A line segment stops at these two endpoints. So this is segment CD, or you could say segment DC. A ray is part of a line that has one endpoint. So there's one endpoint, there's a part of the line, and we'll call this ray PQ, or you could say PQ with an arrow. So these are terms and definitions in 16.1. Okay. Also, make sure to pause the video so you can copy down the notes. Copying down the notes helps with understanding the lesson. So just pause the video, copy down the notes. Alright, next we're going to go over the distance formula. First, the distance is the length of a segment. So it's when you measure the length of a segment. That's what a distance is. The distance formula between 2 points is the square root of the quantity x2 minus x1 squared plus y sub 2 minus y sub 1 squared. In example 1, they want you to find the length of AB, given A is -4, 4, B is 1, 2. So the way to do this is, just like in last semester, label. This is your x1, y1. This is your x2, y2. Once you label your endpoint, once you label your points, you can now just substitute the coordinates into the formula. So x2 is 1, x1 is -4. y2 is 2, y1 is 1. So all I did was use the formula, the distance formula, and I just substituted. We said x2 was 1 minus x1 is -4. y2 is 2, y1 is 4. So make sure you don't forget the negatives in between. So a negative times a negative, that's a positive. So 1 plus 4 is 5 squared. 2 minus 4 is negative 2 squared. You could just use your calculator if you want to verify that 2 minus 4 is negative 2. And then we just square the 5, square the negative 2. So we have 25 plus 4. So the distance of segment AB, that's what this is, the distance of segment AB is the square root of 29. To say this is called the square root of 29. That's how to say this. Distance of line AB is the square root of 29. Okay, next, let's look at example 2. Find the length of GH given G is negative 2, negative 4, and H is 2, 0. So, first thing we do, label x1, y1, x2, y2. Now that we labeled it, we just put it in our formula. Here is y2 minus, x2 minus x1, x2 minus x1 squared plus y2 minus y1 squared. A negative times a negative is a positive, so 2 plus 2 is 4. 0 plus 4 is 4. So we have 4 squared plus 4 squared, which is 16 plus 16. So the distance of segment GH is the square root of 32. So again, the way to say this is the square root of 32. All right, now that we found the distance, we will go ahead and find the midpoint. Since, again, your focus learning target is to find the distance and midpoints of a segment. All right, midpoint, a point in the middle of a segment that divides a segment in two equal parts. Here's the midpoint formula. x1 plus x2 over 2, comma, y1 plus y2 over 2. There's a comma here because we're finding a point. Remember, a point has an x and a y value. Example 3, find the midpoint of segment PR given the endpoint P is 3, 5 and R negative 3, negative 1. Again, what do? We label first. x1, y1, x2, y2. Now we're going to substitute it into our midpoint formula. x1, 3. x2, negative 3. So 3 plus negative 3. A positive times a negative, remember, is a negative. 3 minus 3 is 0 over 2. y1 is 5, y2 is negative 1. So we have 5 plus negative 1. A positive times a negative is a negative. 5 minus 1 is 4, so we have 4 over 2. 0 divided by 2 is 0. 4 divided by 2 is 2. So the midpoint of segment PR is 0, 2. Again, the midpoint of PR is 0, 2. All right, example 4, the last example. Find the midpoint of WZ given W is 7, 0, Z is negative 5, negative 4. First thing we do, label x1, y1, x2, y2. Just like last semester when we found the slope of between 2 points. We labeled x1, y1, x2, y2. So what we're going to do is substitute x1, x2, because the formula, remember, is x1 plus x2 over 2, comma, y1 plus y2 over 2. So x1 plus x2, 7 plus negative 5 over 2. 0 plus negative 4 over 2. Again, a positive times a negative is a negative. Positive times a negative is a negative. 7 minus 5 is 2. 0 minus 4 is negative 4. So we have 2 over 2, negative 4 over 2. 2 divided by 2 is 1. Negative 4 divided by 2 is negative 2. So the capital M means midpoint. The midpoint of segment WZ, again, the midpoint of segment WZ is 1, negative 2. So that's it for today. Make sure to pause the video so you can take the notes. Have a good day.